Hi everybody, and welcome to our Cold Day video lesson. This is going to give you an introduction to linear programming, and I expect you to have gone through this lesson and understood the material by the time you return to class next, whether that's on Friday or next week. Going along with this lesson is the OneNote page entitled 5G 5H. I already put this in your OneNote notebooks a couple of days ago, but if for some reason you're at home, it hasn't synced, and you can't find that lesson, you can always go to HawkNet and look for the assignment that says Cold Day Video Lesson. It includes a link to this YouTube video. It also includes a copy of the OneNote page if you have to download it. You may already have it in your OneNote. Make sure you've got OneNote open right now, and let's go. All right, here we are in OneNote lesson 5G 5H, and you're going to have to put on your analytical thinking caps. Yeah, I know, it's a day off. Tough. Do it. Here's the situation. The Dovetail Carpentry Shop makes two products, bookcases and desks. Each bookcase requires 5 hours of woodworking, things like sawing and assembling boards and so on, and 4 hours of finishing, sanding, staining, painting. Each desk that they make requires 10 hours of woodworking, but only 3 hours of finishing. Each month, the shop has 600 hours of labor available. Maybe they've got some full-time employees, maybe they got a few people that come in part-time, but each month they have 600 hours that they can spend on woodworking. They have only 240 hours available that they can spend on finishing. Now the profit on each bookcase is $40, and the profit on each desk is $75. How many of each product should be made each month in order to maximize profit? Now obviously they're going to make more if they sell more desks, but they may not have enough labor available to make all those desks, so maybe it'll be better for them to make some bookcases and some desks. We're going to figure out how that works over the next 15-20 minutes or so. So let's do some analysis right here. I want you to find out, what would your profit be in the following situations? If they made 0 desks and 20 bookcases, 20 desks and 20 bookcases, 50 desks and 0 bookcases, and so on. Pause the video now and answer each of these 4 questions. Just give me a dollar figure by each one of these. Pause the video. When you have your answers, resume the video. Resume the video now. Okay, here's the answers you should have gotten. $800 if they made no desks and 20 bookcases. That'd be 20 times 40. $2,300 for 20 desks and 20 bookcases. $3,750 for 50 desks and 0 bookcases. $4,500 for 60 desks and 0 bookcases. Now, you're going to have to tell me, could you possibly make the following combinations? Now, the way you're going to tell this is you are going to see if you have enough labor available to do all the required woodworking and all the required finishing. So I've given you 7 scenarios here. I want you to give me a yes or a no. Yes, they could make 10 desks and 60 bookcases because they've got enough woodworking and finishing hours, or no, they couldn't. If you write down no, you have to tell me why. Not enough finishing hours or not enough woodworking hours. So pause the video and answer the 7 questions right here. Pause the video now. Resume the video now. All right, here's the answers you should have gotten. Let's see. No on the first one. You can't make 10 desks and 60 bookcases. Why? Because there would be 270 finishing hours required, and you've only got 240. No, you couldn't make 5 desks and 60 bookcases. That would require 255 finishing, and you don't have it. Yes, you could make 60 bookcases with no desks. Yes, you could make 40 desks and 20 bookcases. Yes, you could make 40 desks and 24 bookcases. No, you couldn't make 50 desks and 24 bookcases, because that would require a few more finishing hours than you have available. You've only got 240 available. So maybe if we back down the number of desks, yes, you could make 48 desks and 24 bookcases. That would work. So you see what we're doing here? We're trying out a few things that are feasible and wondering which one's going to give us the best profit. Obviously, the more things we sell, the better we're going to do. I found that I could make 40 desks and 24 bookcases. Obviously, it's better to make 48 and 24 because that's going to give me more profit. But I couldn't have made 50 and 24 because I don't have enough labor to do that. So now, rather than just doing lots and lots of guess and check, let's figure out how to do this and get it right every time. That's going to be the linear programming algorithm. It's a technique that finds the best answer to a linear function. Linear function would be like the profit in the example above. Our profit was profit equals $40 times each of the bookcases we made, let's call that X, plus $75 times each of the desks we made, we'll call that Y. That's a linear function. I want to get the best one of those, the highest value. Linear programming will find both the best and the worst of any linear function that's subject to one or more constraints. Our constraints here were you couldn't use more than 240 hours of finishing or more than 600 hours of woodworking labor. Now, the technique involves graphing the constraints, those are the inequalities, and finding the feasible region that satisfies all of the inequalities. That should sound familiar to you because we did that in our lesson 6 or 5F right before you got this day off for cold. So before we start doing it for linear programming, let's just review. I'm going to give you a few inequalities and ask you to graph them. I want you to graph this one, x greater than or equal to 0. Then I want you to graph y greater than or equal to 0. Then let's just pick 5x plus 10y less than or equal to 600, 4x plus 3y less than or equal to 240, and then put all 4 of them on the same graph. So go pause the video and go up to this point. Graph all of these. Shade the side or the parts of the graph that satisfy the inequalities. So pause the video now. Resume the video now. Okay, we're back. Here's how you should have done for the graphing. To graph x greater than or equal to 0, we put the vertical line at x equals 0. We shade the part to the right. To graph y is greater than or equal to 0, that one's a horizontal line. We shade the part above it. To graph 5x plus 10y less than or equal to 600. How many of you were just paralyzed with this because there was a number like 600? And that's a big number. Well, let's not be paralyzed. All we need to graph a line is 2 points on the line. I could put this into y equals mx plus b form, but it's far simpler for me just to say, what happens if x equals 0? Then I get 10y equals 600, y equals 60. So that point's on the line. What happens if y equals 0? I get 5x equals 600. That means that x is 120. That point's on the line. I connect these in a line, and I shade the appropriate side. And my fourth one, 4x plus 3y less than or equal to 240. What happens when y equals 0? X is 60. What happens when x is 0? Y is 80. Connect these in a line, shade the appropriate side. Now let's put all of those together. I'm going to get something that looks like this. I'm going to just draw the feasible region for you. I get the part here. that's along the y-axis up to here, something that's along the x-axis over to 60. Then I'm getting something that was the line here that went from 80 down to 60, and I had the line that went from 60 over to 120. So somewhere around here is where those two intersect. Let's get the feasible region shaded in nicely here. Oh, look at that lovely coloring. All right, now it's going to be useful to me to know what these vertices are of the feasible region. This one, 0, 0. This one, 0, 60. This one, 60, 0. Now what's this one? I need to know it. Looks like somewhere between 20 and 30 for X, somewhere between 40 and 50 for Y. How can I tell exactly? Well, it's the intersection of this line and this line. So if only there were a way for me to simultaneously solve two equations, 5x plus 10y equals 600, 4x plus 3y equals 240. You know, we've just spent a couple of weeks solving systems of equations. You can do this. You can do it with elimination. You can do it with substitution. And you should get x equals 24, y equals 48. So this is the point 24, 48. If you are not certain how to do this, go back and review how to solve two linear equations. There's several techniques. You need to be able to find those. And in fact, when you take your quiz, you need to be able to do that, because when you shade a feasible region, I want to know what the vertices are. Okay, now that I've got this, the feasible region is the quadrilateral that's bounded by all of those lines. What does that have to do with my linear programming? Well, what were those silly inequalities I gave you? Let's write an inequality that says you can't make a negative number of bookcases, where x is going to be the number of bookcases and y is going to be the number of desks. So what's the inequality that says you can't make a negative number of bookcases? X has to be greater than or equal to 0. What's the inequality that says you can't make a negative number of desks? Y is greater than or equal to 0. What's our inequality about having only 600 hours of woodworking? If you use 5 hours for each bookcase, that's 5x, and 10 hours for each desk, that's 10y, that has to be less than or equal to 600. Does that inequality sound familiar? Did you perchance just graph that one? What a coincidence. Now, you need to write an inequality that says if you use 4 hours of finishing for each bookcase, that'd be 4x, and 3 hours for each desk, that can't exceed 240. And those are the 4 inequalities that you just graphed and gave me this feasible region for. Those 4 inequalities give me that feasible region with those 4 vertices. Now, let's talk about what the linear programming algorithm is all about. Write a linear objective function that you want to find the maximum or minimum value for. For us, that's profit. Profit equals 40 for each desk plus 75 for each bookcase. Write a series of linear inequalities that express the constraints in the problem. We just did that. X greater than or equal to 0, y greater than or equal to 0, 5x plus 10y less than or equal to 600, and 4x plus 3y less than or equal to 240. Determine the feasible region that satisfies all the constraints. We did that. It was this quadrilateral, 0, 0, 0, 60, was it 24, 48, and 60, 0. Find the x-coordinates of all the vertices. Done. Now we're going to evaluate the objective function at each vertex. Anything that's inside the shaded area is going to be feasible. I can make this number of bookcases and this number of desks. But I can make more bookcases. I can make more desks. I can be moving up. I can be moving to the right without exceeding my constraints. I exceed the constraints once I pass the boundary of the feasible region. So I want to push as far as I can to the boundary. That means that my best value is going to be one of the vertices, either this vertex or this vertex or this vertex or this vertex. My very best value for profit and my very worst value for profit, the only possible choices for those are those 4 points. So how do I finish up a linear programming problem? Here's my x, here's my y, here's my objective function, in our case profit. I'm going to write down all the possibilities: 0, 0, 0, 60, 24, 48, and 60, 0. Now I evaluate the profit for each of those. When I make no desks and no bookcases, my profit is 0. If I do 0 desks and 60 bookcases, my profit is 4,500. When I do 24 and 48, my profit is 4,560. I believe that's one of the ones you did at the very beginning of this lesson. What a coincidence. When you do 60 and 0, my profit is 2,400. One of these 4 is the minimum, one is the maximum. So the best profit is this one. Here is my answer to the question, how many should this carpentry shop make? Right here. 24 desks, 48 bookcases. Now, I also know that the worst is right here. But that one you probably guessed. Sell nothing, you make nothing. Best and worst will be vertices. That's it. That's the linear programming algorithm. When you come back to class, we're going to do more examples. But I expect that you understand this example thoroughly. Enjoy the rest of your snow day. Go do your other homework. See you when you get back.